Welcome back to the DSA playlist. So we are going to solve the second problem in this playlist. The problem title is best time to buy and sell stocks. So let's try to understand the problem statements. You are given an integer array which is prices, and this array consists of stock price on a particular day. For example, if we have got something like 7 1 5 3 6 4, so this represents 7 represent the price on day 1 represents the price on day 2, and 5 represents the price on day 3, so and so forth. What you are supposed to do is that you have to find those days at which one can choose to decide buy and sell such that the profit will be maximum, and I have to return that maximum profit that could be obtained from this information. For example, if I buy this stock on day 1, that is 7 rupees, and if I sold it on day 2, which is 1 rupees, so the profit would be 1 minus of 7, then it will be minus 6, so it's a loss. Like that, for example, suppose if I bought it on day 2, that is 1 rupees, and if I sold it on day 3, that is 5 rupees, then the profit would be 5 minus 1 4. Like that, I have to find those days, and I have to find what could be the maximum profit I could be obtained. So basically, what needs to be done? Find those days. For example, if the day to buy is I and day to sell is J, then find the difference between price on this jth day and on the ith day, and that will be profit, and that has to be maximized. Instead of going one by one, I can straight away tell you the answer for this particular example, that is buy on day 2, that day the price is 1, and sell it on day 5, that day the price is 6, and the profit made is nothing but 6 minus 1 5. This is what we need to return. Even though we are aware of which day to buy and which day to sell, this is the information we need to return. In terms of what they are expecting us to return, these are irrelevant, but without this information we cannot achieve this thing. So this is what we need to return. That's the problem statement. So if there is no profit can be made, for example, if the prices is something like 10 1 1 1, here you can see in this particular example you cannot make profit at all, because the latter part of the values should be higher than before something. So in that case you just have to return 0, that means no profit. That's what we need to find. If you understood the problem statement and all, we can go and try solving. How we can solve? Yes, there is a brute force method. Brute force method is nothing but find all I comma j pairs, and the constraint is j should be greater than I, because you cannot sell it if it is coming before the day. For example, you cannot buy anything on day 3 and you cannot sell it on day 2. So it has to be in that time ordered series, time ordered fashion. That's why this particular constraint. And find all the profit can be made with that particular counting experiment, and then out of that just return what could be the maximum profit one could get. So for that, how we can do is that we can keep a pointer I here in this particular point and keep another pointer here j, and what you can do is that move the j pointer here, and initially for this pairing calculate the profit, then move j to here, then these two pointers find the profit, then move the pointer again, move the pointer again, move the pointer again. Like that we are going to calculate the profit that could be obtained for all the possible pairings, and out of all the possible pairings we would be returning the maximum profit that could get. So let's code that thing. Class solution, and this is a method inside the class. Find max profit, and the arguments are a array is given which is named as prices, which is a list of integer. We understood it from the problem statement. Other than that, nothing is given, but it is expected to return an integer. So this is the return type, integer. So let's fix a variable. The variable is maximum profit, let it be 0. Then I am going to fix these two pointers which I have set. For I in range of length of prices, instead of writing length of prices here, if I want to use that number more frequently, I can define it somewhere like n is equal to length of prices. By this way it can be more handy. So I in range of n, then for j in range of starting from I plus 1. If I is here, j is nothing but I plus 1. If I is here starting, then j should start from here. So I plus 1, and it should go up to n. And maximum profit should be updated as maximum among the maximum profit, and or prices of j minus prices of I. So once the price of I comma j, like price of j minus price of I, gets bigger than the maximum profit at that current instance, this variable will get updated, and at the end we just need to, as per the problem definition, we need to return maximum profit variable. And the question is, what is the time complexity? The time complexity here is that there is a n times iteration here, and again back to back n times iteration here. So it would be the order of n square. Since we are not using any extra space for any purpose, the space complexity is order of 1. And the question is, can we make it better? Yes, we can make it better. So there is an optimum way to do it, that is by single traversal. For example, we just need to go in a single traversal and we just need to use that. So I'm going to copy few of the information that can be useful for that particular example also. Let me copy this test better solution, better one. And here what I am going to do is that I am going to create another variable also, which is minimum. Let it be prices of 0, the first element. And as I go, what I'm in this problem, what I'm going to do is that as I go through this particular array prices, I'm going to find what could be the minimum value that is possible to find this particular things, and the maximum profit would be updated in such a fashion the existing point of the pointer and the difference between the minimum value we have already assigned. Maybe intuitively it is not that clear, but we can understand while we coding. So what we are going to do right here is this: we are going to traverse only single time for I in range of n. We are going to update the minimum in such a fashion: minimum equals minimum between minimum min is an inbuilt function, just like max is an inbuilt function we have used here. Min is also an inbuilt function that finds minimum among a pair or sometimes more than numbers. So what is the minimum among already existing minimum value or the price at that particular instance, and the maximum should be such that maximum among the already existing maximum or prices of I minus minimum. So this way, in a single iteration, we are going to find out the maximum profit one could obtain from this solution. And once this iteration is over, this is our answer, the maximum profit we are going to get, and we have to simply return it. Return maximum, and this is the answer. And what is the time complexity here? Here time complexity is order of n, because only one time it is getting iterated, and that time itself, instead of generating all the pairs, that time itself we are going to arrive at our particular solution. And what is the space complexity? Space complexity is the order of 1. So with that, we have explained the problem statement and solved it using brute force, as well as a better solution which gives much better efficiency. So that's it. Thank you.